JetZero's aircraft may have one of the most radical shapes ever proposed for a commercial airliner. Instead of putting passengers inside a long cylindrical fuselage and attaching wings to it, JetZero blends the body and wings into one lifting surface. That could dramatically reduce aerodynamic drag, and that's what makes the concept so interesting. But there's a catch. The same shape that gives a blended wing body its aerodynamic advantage also creates a completely different set of engineering requirements. NASA research has identified several major challenges associated with large blended wing body aircraft. So if the aerodynamic idea is so promising, what does it take to turn that idea into a real commercial airliner? Look at a conventional airliner. You have a fuselage carrying the passengers, two wings producing most of the lift, and a tail controlling the aircraft. It works extremely well. But the fuselage isn't being used as a lifting surface in the same way the wings are. A blended wing body changes that. Instead of treating the body mainly as something being carried through the air, the body becomes part of the aircraft's lifting surface. That allows much more of the aircraft's shape to contribute aerodynamically, while reducing some of the penalties associated with a conventional tube and wing layout. The U.S. Department of the Air Force says blended wing body designs could reduce aerodynamic drag by at least 30% compared with traditional tube and wing aircraft. JetZero says its future Z4 could be up to 50% more fuel efficient than comparable conventional aircraft. But that's a company target, not a result already demonstrated by a production airliner. And JetZero is now building a full-scale demonstrator with first flight targeted for 2027. So the interesting question isn't whether the concept has aerodynamic potential. It's what engineering problems have to be solved before that potential can become a certified passenger aircraft. One of the biggest engineering questions for a large passenger blended wing body is something passengers normally never think about: air pressure. At cruising altitude, the pressure inside an airliner is much higher than the pressure outside, and there's a reason conventional aircraft use a roughly cylindrical fuselage. A circular fuselage is an efficient pressure vessel shape because its curved shell can carry internal pressure primarily through membrane stresses. Now imagine taking that tube and making it much wider and less circular. The structural problem changes. Instead of relying primarily on the efficient pressure vessel behavior of a circular fuselage, engineers have to account for more complicated load paths, including bending and deformation. NASA research has specifically identified the non-circular pressure vessel as one of the major challenges associated with blended wing body aircraft. And this matters to JetZero because the eventual Z4 is intended to carry passengers inside that unconventional central body. So the question isn't whether JetZero has publicly reported a pressure vessel failure. It hasn't. The question is whether engineers can design a lightweight, non-circular pressurized structure that can safely perform its job throughout the aircraft's service life. That's a challenge the architecture itself creates. Then there's another major question for a blended wing body aircraft. How do you control an aircraft without the conventional tail arrangement? A normal airliner has a tail. The horizontal stabilizer helps control pitch. The vertical stabilizer contributes to directional stability and control. A blended wing body can be designed without that conventional tail arrangement. But NASA research has shown that removing the conventional tail creates important stability and control challenges that have to be carefully designed and tested. The aircraft has to remain stable and controllable across its flight envelope, including situations such as high angles of attack and low-speed flight. This is one area where JetZero has publicly shown that testing is already part of the development process. JetZero says its Pathfinder program has built and flown 5 generations of scaled aircraft over more than 30 flights. The company says its most recent Pathfinder flights are being used to validate the configuration and control laws of the full-scale demonstrator. That doesn't mean JetZero is experiencing a control failure. It means the company is using flight testing to demonstrate that its particular configuration and control system work as intended. And that's exactly what a technology demonstrator is supposed to do. Then there's propulsion. On a conventional airliner, engines are usually mounted beneath the wings in a configuration refined over decades. JetZero's configuration is different. Its engines are positioned on the upper rear portion of the aircraft. And NASA research has identified propulsion airframe integration as a major blended wing body engineering challenge. Why? Because once the engines are placed close to the aircraft's body, the airflow around the airframe and the airflow entering the engines become part of the same design problem. The engine installation can affect the aircraft's aerodynamics, and the airflow reaching the engines can also be different from the clean airflow an engine would experience in a conventional installation. So again, we're not saying JetZero is having engine problems. We're saying the configuration creates a propulsion integration problem that the program has to solve, and JetZero is actively working on that. For its full-scale demonstrator, JetZero is working with Pratt & Whitney and Collins Aerospace on the propulsion installation. The demonstrator uses a PW2000 family engine, while the production Z4 is expected to require more thrust. So even the propulsion system is an area where the final commercial configuration still has to be developed and demonstrated. Then we reach another major challenge. How do you actually build an aircraft with this structure? The unusual geometry changes the aircraft's load paths. NASA research on blended wing-body aircraft has identified more complicated structural load paths and the need to develop lightweight structures for the non-circular passenger cabin. JetZero's approach makes extensive use of advanced composite structures, and that makes sense for an aircraft where keeping structural weight under control is critical to achieving the aerodynamic and fuel efficiency advantages of the concept. But there's an important distinction. Building a demonstrator proves that engineers can manufacture an aircraft. Building a commercial airliner means proving that the aircraft can be manufactured repeatedly, consistently, inspected, maintained, and supported throughout its service life. We don't know whether JetZero is currently struggling with any particular manufacturing problem. What we do know is that JetZero is preparing for the much larger production challenge. The company has broken ground on a major manufacturing and final assembly campus in Greensboro, North Carolina, intended to produce the Z4. So the question eventually becomes, can this unconventional architecture be turned from an engineering demonstrator into a repeatable commercial product? And then there's perhaps the biggest test of all, certification. A conventional airliner has decades of engineering experience behind its basic architecture. Manufacturers have extensive knowledge of how conventional fuselages behave under pressure. They have established methods for analyzing, testing, inspecting, repairing, and certifying those structures. A large passenger blended wing body has a very different architecture and, importantly, does not have the same depth of commercial airline operational history. That doesn't mean certification will be impossible. It means the aircraft has to demonstrate that this new configuration can satisfy the same fundamental safety requirements expected of any commercial airliner. The long-term goal is to prove that this radically different architecture can operate safely and reliably as a certified commercial aircraft. And that's what makes JetZero's aircraft so interesting. And JetZero is now trying to demonstrate that its particular design can overcome them. It has a compelling aerodynamic case. The difficult part is proving that the aerodynamic concept can become an aircraft that survives every pressure cycle, every gust, every flight, every inspection, and years of airline service. And that's the real engineering challenge JetZero has chosen to take on.